All right, so this is a mastery lesson. This ties to the previous class period. On the formative, if you received a 7 or a score of 8, you should be in this lesson. This lesson is going to go into how to create a Bohr model. You can add the Bohr model to your developing a model worksheet for your molecule, and it's a great way to just extend your learning as well. So our success criteria, we're going to draw a Bohr diagram of different atoms. Your previous success criteria, which also flows into this lesson, you should be making a model of an extended structure for mastery. You should be researching information about your chosen molecule on the internet, and you should be choosing your final product and begin creating it. So here is a representation of a Bohr diagram. If you look in the center, you'll see where it says 10N and 9P. So this is an abbreviation. We're looking at the nucleus, and so we know that in the nucleus are neutrons and protons. So 10N is the amount of neutrons, and 9P represents the amount of protons. You'll notice when we create Bohr models that there are a lot of abbreviations, including the element name. We will be using the symbol more so than writing out the entire element name. When we draw a Bohr diagram, in the center, there is a nucleus, which holds protons and neutrons, and around the nucleus are electrons. Those will be shown in rings, but we will also refer to those rings as energy shells. If you look at the diagram at the bottom of this slide, you'll see an example of phosphorus. In the center, again, you'll see 15 protons and 16 neutrons, so you'll see protons and neutrons abbreviated. But you'll also see rings around the nucleus, and those are the energy shells, which shows the amount of electrons that phosphorus has. Here are the steps on how to draw the Bohr diagram. We're going to use these steps on the next couple slides in order to draw a diagram. It is great to have scrap paper around the house or anything near you, so you can go ahead and pause the video now to make sure you have scrap paper so you can practice drawing these Bohr models with me. All right, so the first step, we're going to write the name of the element. We're then going to draw a circle, and inside we're going to put P for protons, and we're going to put N to represent the amount of neutrons. We're then going to have to determine the number of electrons so that we can properly put those in the energy shells around the nucleus. We're going to start off by drawing our first 2 electrons in the first energy shell, and then we will draw circles and electrons until all electrons have been accounted for. So here's an example of neon. Go ahead and find neon in your periodic table. You should have a periodic table in front of you, and if not, go ahead and find one online and locate neon. So for neon, you'll notice that the first shell has only 2 dots in the center. We have an electron here, and we have an electron here. The second shell has 8 electrons. 4, 5, 6, 7, and 8. All right. So if we add those electrons together, that would give us 10 electrons. When we look at neon on the periodic table, we will also see that neon has the atomic number of 10. That tells us that neon has 10 protons, and we know in a neutral atom, the number of protons will be equal to the number of electrons. We're going to draw an example from scratch on the next slide. All right. I'll take my eraser here to erase the previous electrons. So now use your periodic table to find lithium. You'll find lithium in group 1, so that's going to be the column furthest to the left, and you should see it towards the top. So we have lithium. On your formative yesterday, you demonstrated knowledge that the atomic number would be 3, and that would tell us how many protons it has. So I'm going to write 3 at the top here. And we know in a neutral atom that the number of protons will also be equal to the number of electrons. So I'm also going to put 3 for the number of electrons. To find the number of neutrons, We're going to take the atomic mass at the bottom, and we're going to round this up to 7. In your formative, you demonstrated knowledge that the atomic mass comes from the number of protons and the number of neutrons that are located inside of the nucleus. And so if we know that lithium has 3 protons, we're going to take the atomic mass of 7, and we're going to subtract the number of protons from lithium. We know that it has 3 protons. And that's going to give us the number of neutrons, which will be 4. So now that we have this information, we can take this information and we can start to construct our Bohr diagram. On the right, we're going to put in the center of the nucleus the number of protons and the number of electrons. So we're going to put 3, and we're going to label that with a P. That tells us that there's 3 protons. We're then going to put 4, and we're going to label that with an N. That tells us that there are 4 neutrons. We then need to place our electrons properly around the nucleus. Our first energy shell holds up to only 2 electrons. So we'll put our first 2 electrons in the first energy shell. And that will leave us with 1 electron left over. We're going to take that third electron and we're going to put it in the second energy shell. All right? And when you're done, your Bohr model should be similar to this. We're going to do another example with more electrons. And where do we properly place those electrons around the energy levels? So I'm going to go ahead and erase this. And let's go and do another example on the next slide. All right. Example number 2, sodium. Find sodium on your periodic table. It has an atomic number of 11. And I want you to go ahead and draw a Bohr model for sodium using knowledge from the previous slide. So you can go ahead and pause the video now and then draw sodium and then come back to the video so that we can go through it together to make sure that it's drawn correctly. All right, so by now you should have your model of sodium. We're just going to go through it together to double check. So our protons, we know that it has 11. We know that's similar to the number of electrons. And the atomic mass, if we round out, that will give us 23. And so our neutrons, we will put 12. Let's put our protons and neutrons in the center of the nucleus. All right. And now we are going to go to the electrons for sodium, and we're going to put the electrons in their proper positions around the nucleus. So the first energy shell, if we remember, the first energy shell holds up to 2 electrons. The second one will hold up to 8 electrons. And we'll go up to our third energy shell as well, which can hold up to 8 electrons. So let's put our first 2 electrons in the first energy shell. That will leave us with 9 electrons left. So then we're going to put our remaining electrons in the other energy levels. But remember, this second energy level can only hold up to 8. So we'll put 1 here. 2, 3, 4, 5, 6, 7, and 8. All right. And so if we count the total number of electrons, we currently have 10. Our electron number 11, we're going to put that in the third energy level. So we're just going to place that here in this third energy level. And when we count all of our electrons, it should total up to 11 total. So this is a proper Bohr model for sodium. You can look at the elements within your molecule and draw the Bohr model for those particular elements using a similar method. I'm going to go ahead and take my eraser, clear the screen. All right. So it's great to practice Bohr models to check them. And so in your notebook, if you have your notebook or even just on your scrap sheet of paper that you have, go ahead and draw a Bohr model for chlorine and then also draw one for oxygen. And then go ahead and pause the video lesson at this point to draw them and then come back to check in. All right, so you should have chlorine and oxygen drawn. This next slide, go ahead and compare these diagrams to the diagram that you drew either in your notebook or in your scrap piece of paper. Look at the number of electrons, count them, and also look at their placement in the outer energy levels. You may be concerned about where the electrons are placed in comparison to where yours are placed. At this time, we're not going to focus specifically on exactly how to place them, as long as you have the correct amount in each energy level. However, it is best if you look at the structure of chlorine and how there's two dots and they're in similar places, it is best to keep them as organized as possible. It helps you to count them a bit better. And finally, if you're ever just a bit confused on how do we know how many electron shells to add, how many electrons do we place, and so the first electron shell can fit up to 2 electrons. In order to figure out which elements fall under that, if you look at your periodic table, the periods go across in rows. And so the elements that are in the first row will be in our first period. Those elements will have 1 electron shell, which can hold up to 2 electrons. So if you see helium and hydrogen at the top of your periodic table, both of them have 1 electron shell, which can hold up to a maximum of 2 electrons. It may just have 1 electron, but it can hold up to 2. If you look at elements in the second row, that's where we have lithium, and you can go across. Those elements will hold up to they will have 2 electron shells, where the second shell can hold up to 8 electrons. This is a great slide to come back to in case you're a bit confused, where you can look at your element, figure out which period it's in, but also where do you place the electrons properly around to create the Bohr model. If you have any questions, please reach out to your teacher through Google Hangouts. You can also reach out to us through email. We're always available. If you want us to just give a bit of feedback on your Bohr models that you've drawn, you can also share those with us as well. All right.